So today we're gonna continue our vlog and live streaming for another topic which is related to angular motion and rotational motion. Okay, we need to understand another terms and quantities: the angular momentum and the torque. Okay, so how can we understand this one? So if we try to recall the topics of the second law of Isaac Newton we have there, if the object in motion will remain in motion if unless acted by a net force. Okay? With the point. And you have also the law of inertia, second law, right? And the first law of inertia is the object at rest will remain at rest unless acted by a net force. Okay? So if the net force is zero, there will be no motion. There will be no velocity, there will be no speed, something like that, of a certain objects in motion, something like that. Okay? So for example, guys, we have momentum, right? Momentum. Because we're dealing here with angular momentum, so we need to talk about momentum also. Okay? So momentum. The momentum is defined as mass times the change in velocity, or delta v, like that. The symbol is letter P. Okay? Something like that. Mass times the change in velocity is equals to P. P is the symbol for the momentum. And this is linear momentum. Okay? Linear momentum. Okay. So for example, if you have point 1 and point 2, so you're gonna say that you have at point 1 at point 2 in a linear momentum theory, we're gonna say m1 v1 is equals to m2 v2, like that. Okay, we'll just have an assumption on a steady state motion like that. Okay, at point 1 and point 2. Now, if it is really conserved, okay, it's gonna be like m1 v1 plus m2 v2 is equals to m1 plus m2 times the final velocity. Then therefore final velocity is equals to m1 v1 plus m2 v2 over m1 plus m2. This is gonna be when the momentum is conserved. Okay, and you can also imagine with a type of problems when you face that kind of problems in the future. Okay, so you can use this formula, but the simple momentum is only mass and the change in the velocity, and the variable is letter P. Okay, this is linear momentum. Okay, now how about angular momentum? Okay, angular momentum. Aside from knowing the fact that in terms of angle and inclination, that's why angular, right? There's an angle of inclination. Okay, meaning there's a circular motion like that. Get the point? So, or there's gonna be a rotational motion, something like that. Okay, for angular momentum. Okay, something like that. There's an angle of inclination, and it could have been a rotational motion. So that's the difference between angular momentum and the momentum. Okay, something like that. Now this linear momentum, guys, this comes from the second law of Isaac Newton, as what I discussed just now. So we need to derive that also. Okay, so that we can relate that to the impulse. Because sometimes there is also, or there are also problem solvings that they try to connect the impulse to the momentum, something like that. Okay, since we know that the impulse is really the rate of change of the momentum. Okay, the definition of impulse is the rate of change of the momentum, or it is specifically the force times the time. So how can we do that? Okay, so for example, if this is a second of Isaac Newton, force is equal to mass times acceleration, something like that. Okay? So, wala na kayo like that. Okay. So, it's gonna be like that. Okay, so force is equals to mass times acceleration. Since acceleration is equals to the velocity over the time, right? Okay, this is acceleration. Okay, you get the point. Now it's gonna be like we will substitute the second law of Isaac Newton. Is gonna be force is equals to mass times velocity over the time. So since the velocity and the speed, or let's say the velocity, always keep changing most of the times, especially when you walk, when you drive the car, or whatever, it's not really always constant. Okay, that's why this is gonna be change in velocity delta v and delta t. So subject for any changes. It's not all the time constant, especially, for example, when you jog, you don't have the same speed all the time because you are tired. When you walk, you are also tired after 20 minutes. So there's gonna be no constant motion all the time. That's why in our equation, you need to put that as a change in velocity or a change of time. The same also with time. Okay? For example, when you walk to a certain destination every day, like that in your work, only example, then you can also say that you will always be there in the same time all the time because it depends on your speed, how you manage to walk. Okay, so it's gonna be like that. That's why we need to introduce the delta or the change in velocity over the delta change in time. Okay, get the point. Anyway, it is obviously stated in the problem. And at a constant rate, blah blah blah, so and so, at a constant motion, blah blah blah, so and so. So you need to treat that, really, the time is constant, like that. Okay, the velocity is constant. So it will help you a lot to analyze the problem, something like that. But in here, so we'll say force is equal to mass and the change in velocity and the change of the rate of change of velocity. Okay, always take note the terms, the rate of change of blah blah blah, the rate of change of blah blah blah, so that you can understand. So that is really with respective to time in the denominator. For example, I will say blank is the rate of change of velocity. Your answer will be acceleration. Blank is the rate of change of displacement. Your answer will be velocity. Blank is the rate of change of distance covered. It's gonna be your speed. Okay? So you will take note that the time is always in the denominator if you refer to the rate of change blah blah blah. Okay? So that's the theory, because you can convert that in a formula or equation even though you're only memorizing the statement. Through that you can create the equation and the formula out of that. You get the point? That's why it's very very important also. Okay? Ganon. So if you have now here force is equal to mass and the changing velocity over the time, then we need to do the math. Okay, algebra, cross multiplication. So we force times delta t. Okay, force times delta t is equal to the mass times delta v. So now in here you could create another equation that focuses on the impulse. Force, the change in time is the impulse. Okay, so it's gonna be impulse. Okay, so it is equal to the momentum, mass, and the change in velocity. Okay, momentum. Okay, get the point. At the second law of Isaac Newton, it's very clear that the impulse will be just equal to the momentum. Okay? You get the point? So if the theory question will say in the future, what will happen? Okay? With regards to the impulse and the momentum in the second law of Isaac Newton. A, the impulse is higher than the momentum. B, the impulse is lesser than the momentum. C, it will never change. D, impulse is equal to the momentum. Your answer will be the impulse will be equal to the momentum in the second law of Isaac Newton, the three laws of motion. So it's gonna be like this is theory. Okay, already here. So we need to say your equation back up your theory. You need to say your background, your parent, understanding rely on the theory and the concept. You have only the math and the equation and the formulas to prove that the theory is correct, reliable, logical, and is really subject to factual and reality in our daily situations in our life. Something like that. Okay? To the point. Okay, because every day of our lives we do momentum, we do impulse. Okay, because time is always have around us, 24 hours. So we already have the delta T. Okay, then when we walk, we have the mass of Joule. So we have the mass also, see? When I walk, it covers a motion. So all the quantities here in our equation, we apply that in our daily life. This equation. Only that, we don't compute. Okay? We don't compute because it looks like so theoretical if we keep on computing the impulse that Junjun delivered in his office during his work, something like that. It's not look practical, but what we are trying to emphasize here, at least we understand that there's gonna be like that existent if we're trying to understand around us, the nature around us, because this is in our nature. Okay? Even though you walk naturally, you will be having the impulse and the momentum. Okay, this is gonna be the linear momentum. And now we connect that to the angular momentum. So, okay, at least we now have the exact understanding or the precise understanding what is really a momentum, linear momentum. Okay, so usually guys, momentum applies to like the ball, soccer ball, football, basketball, like that. And then, for example, when another ball hit another ball, and then billiard also, when you hit the ball to another ball, the other ball will move. So it's gonna be the application of the momentum. So M1V1 is also into V2, like blah 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 so and so. Okay? So for example, this is the pencil pen and this is the eraser. The eraser will push this pencil pen, okay, and then they will move and they will stop for a while to a certain point or destination. At that time, this pencil pen and eraser will share the same mass already because they are contacted with each other. Okay, so their masses will be equal, and then that's why we need to add their two masses, something like that, multiply to the final velocity, blah blah blah. So, but if this this mass of the pencil pen will not really still moving and they will never stop, you cannot assume that their masses will be equal, something like that, unless they stop both upon contacting with each other. They will share the same masses, something like that. Okay? You're gonna say mass total is equals to M1 plus M2. Okay? So, wala siya. You get the point. So, it's gonna be like that. So, the one, if it is moving, for example, in my example before, the pencil pen will move when the eraser push during the motion, and then it will tap, like it will move suddenly, it will stop. So that's gonna be inelastic collision. Okay, like those are two types: elastic collision and inelastic collision. The elastic collision, the other one will continue moving when you hit this. Okay, it will never stop. But you get the point? But inelastic collision, when you bump this one, upon bumping, it will cover the distance and both of them will stop. After that, they will magnetize on each other. So it's inelastic collision. Okay. Elastic collision, when this eraser will push this pencil pen, the pencil pen will go directly and will never stop, even though the eraser will stop. Okay, so that's gonna be elastic collision. So there are two types of momentum: the elastic collision momentum and inelastic collision momentum. Okay, something like that. But in angular momentum, that is not really that applicable because usually in the circular path, okay, or usually in the curvature or in a circular, motion, rotational motion. So for example, if I have the angular momentum like this, okay? So, ganon. I have here a circle, full circle, big circle, ganon, di ba? Okay, so, guys, we need to remember the trigonometry math again. Trigonometry. Okay, so for example, if I have here the just like an equator, okay, equator like x-axis halfway in the circle, right? And then, or shall we say prime meridian, right? Something like that. Or then we have also the vertical. Shall we say this is the, let's say, equinox, something like that, or let's say longitude. Okay, if you try to put that in a study of social studies like that, right? We have the longitude, we have the latitude, something like that. The longitude are the vertical axis components, and the latitude are the horizontal x-axis components, so x and y. So in here in the center, let's say in the equator, so let's say this is the Earth, something like that. So this is gonna be our, okay, halfway. We treat this here as, 0, and then here we have 90 degrees in the halfway, and here the 80 degrees, and then we have the 270 degrees. Okay, like that. Just like a pizza pie. If you try to make that perfectly cut or slice it perfectly, for example, if you have if you have one daughter, one son, and you have your wife and your husband, you buy pizza, you will perfectly slice it into 4. So we need to say 1/4. Oh, 1/4 for your son, 1/4 for your daughter, husband and wives. Gonna like this. 1/4 here, 1/4 here, 1/4 here. So your 1/4 is gonna be the 90 degrees here. Okay? Another 90 degrees here, another 90 degrees here, another 90 degrees here. Okay, now this is angle of inclination. For example, if you try to swirl the ball, let's say I am standing, Junjun is standing here in the floor. I'm able to swirl. I will tie the rope, okay, with a ball like that. So meaning to say this will be going circular motion. Okay, so as the ball going to a circular motion, it will correspond to different angles, as I mentioned a while ago. 90 degrees, 30 degrees, 30 degrees. So it's become angular motion. And then it covers an angular momentum due to the fact that the ball has its own mass and its own velocity. Okay, so mass times velocity is the momentum. In angular momentum, guys, mga palangga kong hitan, instead of having the mass, we will consider the inertia, moment of inertia. Wow! Kaloka, di ba? So the moment of inertia will be related to the first law na naman of Isaac Newton, the first law of motion. So moment of inertia. Di ba bongga? Moment of inertia. Moment of happiness. Wow! Di ba? Moment to moment. Okay, di ba? So, like that. So, the symbol will vary also. We have a symbol of angular momentum of the L already. L. Okay? Then the linear momentum is P, right? We introduce another letter or symbol for that. And angular momentum of the L. And then we have the I. Moment of inertia. Like that. Okay, I. Okay. Times the angular velocity. Okay, that's the point. Instead of having the linear velocity, we are now having the angular velocity. Okay, so angular velocity, so the unit will be not the same with the linear velocity. It's gonna be talking of the radian per second, because as we go to the trigonometry, as we travel, for example, here, okay, we have 0, we have here the pi, something like that. 0 angle, meaning equal to a pi, okay, in terms of radian unit. Okay, and then if you go to 90 degrees, it will become, let's say, 1/4 pi, something like that. Okay, correct me if I'm wrong, ha? Mga palangga kumbitan. Okay, and it will go here, mga palangga kumbitan, it will become 1/2, okay, 1/2 pi, something like that. 1/2 pi, right? Because this is the 1/2 of the pi. If you assume that it is a pizza pie, that's why 1/2. That's why we have a pi, because that's the definition. Okay, it's driven by math. The pizza pie, PIE, meaning 3.1416 in math. That's why we apply that in food. Pizza pie. Meaning the pi there is equal to 3.1416. That's why we need to divide that in how many slides. Pi diha guys, 3.1416. So we drive that by math, the word pi. Okay? Like that. After 1/2 pi, we have the 3/2 pi. And then we go back to one revolution or one cycle of a circle, of a circle, it's become 2 pi. No, okay, better understand and then memorize. Okay, what's going to be happening for the sequencing of your pi and what's going to be happening of the sequencing of your angle and inclination. Okay, something like that. Okay, now, okay, we understand really that it is one revolution is equal to one cycle in terms of a circle. Hala, since we can say pala or that one revolution is equal to 2 pi, meaning one cycle. Okay, like that. So one revolution is equals to 2 pi, and then it is also equal to 360 degrees if we try to base that in angle of inclination. Like that. Okay, so you can easily troubleshoot one revolution, 2 pi, and then 360 degrees. Half of it is the pi only. Double the pi, that's why 2 pi. Pi plus pi is equal to 2 pi, math. Okay, something like that. So it's going to be like that, so we understand now. Now, if this is a circle as said a while ago, and this is a pizza hat, for example, then we need to consider the circumference. Okay, the circumference will be the one revolution times the radius. Okay, because it is rotating. Okay, so here radius. That's why it will become 2 pi times radius is our circumference. Okay, it's gonna be like that. I need to connect this because we need to get the angular velocity for this in our angular momentum. Now, if you have the circumference 2 pi r, hala, it's going to be like that. So what will be happening for your velocity in terms of a circle? Here. Because we're dealing with angular momentum, let's connect this later on. So we will say that velocity of this circular path, something like, or curvature or round or whatever, it's going to be circumference over the time. Okay. If we have the linear velocity is something equal to distance over time, then if we have our topic circle round or circular path, it will become circumference over the time. So since circumference is equal to 2 pi r, it will become 2 pi radius times time is equal our velocity for circular motion. You get the point? So for example, if I use my car here, let's say I have my Fortuner Toyota car here, I will be able to rotate in a rotunda, okay, in a roundabout, in a certain, city, for example. Okay, so I will not compute the velocity in terms of distance only over time because I covered in a circular motion. So I will be able to use this velocity is equal to 2 pi r over t. Okay, you need to apply the correct way of your theory when you use the equation and the formulas. Okay, it's gonna be like that. Now, this is the circular velocity, okay, or the centripetal velocity because it's towards the center. Okay, You get the point. Of course, if you're going to the rotonda, your car will be on the center. If not, you will go on the sideway. You will hit other vehicles. You will stay in the circle directed towards the central or the central point of your rotunda, and you will run out. Okay, something like that. You get mga palangga. Now, how can we relate that to angular momentum or something like that? Okay, it's gonna be a moment of inertia. Charot. Okay, so your moment of inertia, there's a lot of formulas for this in which makabuang, pero you will be able only to select the best moment of inertia particular to a certain geometrical shape. So as what I have remembered, I only choose the sphere, the cylindrical, the single mass, and the round chuba chuchu. So if you try to note the single mass, our formula is going to be like only like this, okay? I, moment of inertia for a single mass object will be 1/2 times the mass times the radius raised to the power 2. Equation 1. Ganon. Equation 2. Moment of inertia of a sphere is equal to 2/5 mass times the radius raised to the power 2. Okay, option 3. Moment of inertia of a particular cylindrical or round-shaped object is gonna be 1/2 mr squared. Now, it is very obvious in your problem solving in the future because they will mention what type of shape is that. This really stated in the problem. So it troubleshoot, it extract that it's gonna be, this is gonna be like this because it was mentioned. Okay, if it is not mentioned, the shape, then you will go most likely to the single mass, which is I is equal to 1/2 mr, or use the other formula also instead. We have the I is equal to the radius times the linear velocity. Okay, ganon. Linear velocity. So, it's gonna be like that. Since the topic is more on the circular, chuba chuchu, then you cannot expect the linear velocity because it's circular. Okay, since you have also the formula of the velocity is equal to the acceleration like this, you need to use the angular velocity na talaga siya. Velocity is equal to the angular velocity times the radius, and compute for the velocity and substitute this here so that you can only pasok sa banga of your topic. Because you cannot pasok sa banga if your quantities here are all linear. Okay? If the problem talk about circular, throwing a ball, the car is going like this, curve like that. So you cannot expect this linear formula to be used. So the only chance to think deeply is to correlate the other quantities all about rotational and angular that regards to the angular velocity. Okay, it's here. Okay, guys, the term will be changed if you're dealing with angular things like this. Your quantity will change to something. For example, if you have the velocity, you will say that tangential velocity. The acceleration also tangential acceleration. Displacement also tangential displacement with respect to your angular chuba chuchu. Okay? Your terms will change already if you mix the linear and the angular. You got the point? But if this is all linear, no issue. But if it's a mixture of linear and angular in one equation, then you have to do that tangential, something like that. But if there's no linear, all are angular also, do not use the tangential term. For example, be careful also with the English, how you understand the formulation or equation. It's not always all the time math. You should understand the English, the utilization of the correct terminology of that specific formula and equation to be used. Okay? It's gonna be like, for example, if I will say tangential acceleration, like that. So it will become angular acceleration times the radius. So there's a mixture. There's an angular acceleration, angular motion, right? Or rotational motion. And the radius is simply the linear chuba chuchu. Something like that. Okay. And then if you say tangential displacement, theta is equals to ganon, di ba? Okay. So it's gonna be D is equals to theta times R. O, ganon. So, tangential velocity. Oh, tangential velocity V tan. Okay, V tan is equals to angular velocity times the R. So in your memorization, if you say tangential, you need to account that the radius will be multiplied all the time so that you can easily memorize and you can engrave that in your brain cells. Okay? See? Common is radius all the time. See? R. So, not only to memorize, na? Tangential, ang R, kung ano siya i-multiply. Oh, okay, so that ikaw makalimot. Okay, that's the point. Okay, and then your technique also, if you are referring to the acceleration tangential, you will also deal with the acceleration to multiply with the R. So it's impossible you will forget the formula. Okay, you get the point? If you understand the technique how to do the memorization, okay? Meaning you understand really what's the, the mechanism, like that, whatever. Okay? It's gonna be like that. So going back to angular momentum. Okay. Ganon. I will erase this. So, before going to angular momentum really direct, so, I need to express that's gonna be, for example, so this is going to be a 1/2 pi, right? 1/2 pi. So this 1/2 is dealing with the number or the magnitude. Okay? Since angle of inclination has figure, see, 180, 90, these are magnitude or number, figure, digit like that. Okay? Get the point. Radian is the unit. Okay? Degree is the unit. For example, 90 degree. Degree is the unit, 90 is the magnitude. Something like that. Get the point? So, this 1/2 is the magnitude, the number, the figure, the digit, like that. Okay. Since 1/2, man siya, 1/2 of 360, di ba 180? Okay. So, mana din ka, pi over 180 is your conversion factor if you convert angle into radian. Okay. And vice versa also. For example, convert 32 degrees to radian. You say 32 degrees, okay, times 180 degrees, pi, then cancel the degrees so that you have the pi. And this will become your radian. Ganon. Okay, because you convert the angle into radian. Okay, you get the point. So this is your basis. Okay, you should inculcate this into your brain cells or accumulate or engrave into your brain cells the pi 1 over 180, that this is gonna be the conversion factor from converting pi to angle, radian to angle, angle to radian. The basis will be pi over 180. Okay? Ganon. Then, it's okay also, you will analyze siya, ganun. But, hindi mo gusto na-memorize na hindi mo siya char, apart from understanding. Okay? You get the point. Ana siya mga palangga. So, if going back to the, angular momentum, L is equals to moment of inertia times angular velocity. Now, I introduced you already the formulas of inertia, right? So many guys I told you about it, right? Say, sphere, I is equals to 2 over 5 mr squared. Okay, and we have also the cylindrical. I is equals to 1/2 mr squared for the single mass object. 1/2 mr squared. No, mr squared lang siya, wala yung 1/2, di ba? Okay, now, ang I po niya, di ba, pwede sila siya katong usa sa na F times D. Okay, mean force times distance. Ganon. Diba? Mo sana siya. Umamot, tabi nga siya, gapo na siya. Okay? Okay? So, and then the other one also, moment of inertia is equal to the radius times the momentum, linear momentum. So there's a lot of formula of moment of inertia. Be careful in taking the correct formula to be used. Anyway, it will be mentioned in the problem. Okay? No doubt about it. Okay? So if there's no mention about the problem, okay, I'll ipugos, ipasok sa banga because that is not really applicable. Okay? Like that. So this one, moment of inertia, angular velocity. We go now to the angular velocity. Get the all equations with relation to angular velocity. So angular velocity is equal to, okay, it relates to the displacement. Displacement is equal to angular velocity times time. So let's say angular velocity is equal to the, okay, angular displacement over the time. This is equation 1. Okay, what else? How can you connect the W? We can connect that also the centripetal acceleration, AC, or the radial acceleration, in which we say W squared times R. Then compute for the W is going to be W squared R AC, then W squared is equals to AC over R. Then therefore, angular velocity is the square root of centripetal acceleration over the R. This is also equation number 2 of angular velocity. What else? Okay, what else? Okay, this is also another equation for this in respect to the revolution, which is the popular, let's say, angular velocity is equal to 2 pi radian, like that. So all you have to do is to choose which is the appropriate equations that will be applied in your problem. So W is equal to 2 pi radian times the frequency. Ganon. So tulo na siya. Okay? Okay, then if we try to denote that to the, to the Pythagoras theorem, it's also possible. This is only my own formula used. Okay, now, so I could say also, as I told you, you can create your own formula if you understand. Okay, so this is for the first time. I will introduce a formula like this also. This is not in the book. This is only mine. Based on my correlation. Okay. Meron talaga guys, if you really become, genuine engineer, you know how to manipulate equations and formulas. Okay, even though you will not refer all the times in the books. Okay, get the point. So I will say like this also is gonna be, angular velocity squared is equals to the angular velocity raised to the power 2 in the x component plus angular velocity in the y component. So angular velocity is the square root of the angular velocity in the x component squared and the angular velocity y in the y component. Why? Because it is possible. Okay? If your car will go to the direction of circular, it can create an angular velocity up, angular velocity left, right, like that. And it's an angle because it's circular, something like that. You get the point, mga palangga kungitan. Okay. It's no longer linear because it's running in a circular path. Something like that. You get the point. Okay. Klaro ka siya, linear is only for line. L-I-N-E. Then if you travel in a circle, that's no longer a line. Okay, in English. Okay, it's already circle. Okay, circle, circular. Okay, line, linear. So there's a clear difference when to apply the equations and the formulas. There's limitations. And you should be careful with that also. Okay? Get the point. So, muna siya akong first time na-create because of this. Nagingaw-lingaw ko rin nga formula. Okay? So, that's it for the W. Okay, now, if the torque, ang torque guys, tunga na ni siya kalit kinamang angular motion. Okay, see, torque and angular momentum are jowa. Okay, they are really partners in crime, something like that. If we have angular momentum, we have also the torque. Okay, and torque is very important in the calculation, in the engineering design of different work equipment or any machineries. Because torque really refers to the movement, the motion, accompanying with the distances, the velocity, the acceleration. It's gonna be like a complete package of different quantities in physics. Okay, something like that. So we have the torque. So the torque, like this, represented in the Greek symbol tau, T-A-U. Okay, remember with the chemistry, we have the tau neutrino. Okay, tau neutrino is a one type of electron. because there are 6 types of electrons. Okay, not only one. The popular we know is only the electron that it carries a negative sign, but actually there are 6 types of electrons. Okay, others are anti-electrons. They will not participate in the producing the electricity. Only the electron neutrino is the responsible for the producing of electricity. They drop the word neutrino to make it simpler. But actually that is coming from electron neutrino is equal to electron. Okay. Then they drop the word neutrino to make it simpler. Okay. The scientists use only a very simplified term that they refer that generally as that. They are referring to a certain particle like that. Okay, they drop the word neutrino. That's why until now we use the word electrons. Okay, but actually that's coming from electron neutrino. Okay, that's the history why we have electrons. You get the point? Something like that. So we have the tau. We have also tau neutrino. Ganon. Okay, you get the point, mga palagakmitad. It's gonna be like that. Okay, so this tau, okay, Greek symbol, is equal to the angular acceleration, gano'n, di ba? Times the moment of inertia I also, gano'n. Okay, and then angular moment of inertia, parehas siya. What is their common? Okay, during your memorization, you need to understand that there's a commonality. There's a common of the quantity and we have to insert that somewhere along the way. It's the moment of inertia. Okay? So, ipasok sa banga. There's a moment of inertia due to me. Ano yan? Torque, moment of inertia times angular, okay, acceleration. And then, the angular momentum is the moment of inertia times angular velocity. Ganon. Okay. Ganon siya, guys. Now, guys, kung ang torque mo zero siya, just like the F net will become zero, right? In the acceleration, law of acceleration and the second law of Isaac Newton. Ngayon, sadya ko ng theory, if the torque will become zero, okay, if the torque will become zero, then you will say that your angular momentum in point 1 or initial will be equal to the angular momentum in point 2 or final. So it's gonna be like that also, just like a linear momentum as I told you, right? It will become, okay, I1 W1 plus I2 W2 is equals to I1 plus I2 times WF. Now, if the question in the problem says, what is the final angular velocity? Okay, you can compute that in this way. Final angular velocity is equals to, the initial moment of inertia times the angular velocity initial, okay, plus, okay, moment of inertia final times the angular velocity 2, okay, over the moment of inertia initial plus the moment of inertia final. So something like this. The same with the linear momentum. The only difference, we introduce the term angular, like that. Okay, and also the rotational motion. So put that in your brain cells. That angular is gonna be rotational motion in a circular path. But linear, no, nothing. Something like this. You can easily, I will apply this. Okay, but I remember during our board examination, so what comes out there as far as I could remember is really the linear momentum. Okay, linear momentum is gonna be inelastic linear momentum. So that one. Okay, in physics, I remember. I think there are 2 or 3 questions, something like that before. Okay, so that was 2000, year 2000. Okay, like that. So that's very interesting, right? Angular momentum and torque. Any questions so far for that? So I will introduce you problem solving now so that you can really apply for the application. Okay, or tomorrow na ta, guys. Charot! Okay, I need to introduce only one, only one example. Oh my gosh. Somebody is chatting me. in Bisaya. Oh my gosh, nakakaloka. I cannot express because it's not good. Okay? Not good expression. Because here, see, there's a statement here, sigurado na ang panalo namin ni Kiko. Pag natalo kami, ibig sabihin nadaya tayo. Pag nadaya tayo, magkakagulo. This statement is really negative. Okay? Because if magkakagulo, if you are a lawyer, that is not the correct solution if magkakagulo. You should do it in a legal way because you're a lawyer, you will file a case, okay, against intruders or against people who initiated the fraud and the cheating. To create violence, chaos, or any whatever magkakagulo is not the best solution. It will create problems, so many problems if you do that. Okay? You get the point? So thinking like that you're a lawyer, it doesn't match, right? Because your action is not in legal way. Okay? The more you create, the more you create clashes meaning panagubot, may anak, okay? You get the point? So if you do that, and then our statement, guys, it's not really that professional. Again, this is a lawyer, okay? She said, she's a lawyer. He passed her bar exam after 5 years. But they said they paid money in order for her to pass because Jason Robredo at that time is working already with Noynoy Aquino. Okay, that's what the mystery. For example, if you are a graduate of, let's say, mechanical engineer, okay? And then after 5 years, you will take the board examination. It's either the two. You will become a top-notcher or you will never pass. Why? First scenario, you will become a top-notcher because 5 years you are studying very, very well. You get the point? And then you will also fail because you are now married, you have children, you don't have time anymore to study, things like this. You are busy now, you forgot now because now you are now in the real world, something like that. Okay, so it's gonna be like that, but she is not a top-notcher. Okay, so she passed only. So meaning to say there's something wrong. Okay, you get the point. And according to Thinking Pinoy, who is a BS Math graduate of, I think, University of the Philippines, something like that. So she cannot show really the authenticity of her, records in the bar exam until now. Okay? Really, it doesn't match really this kind of situation. And every time she spoke also in the tablet, she never stated any single article or a public act or any bill number that could really emphasize that you are really a lawyer, right? During your explanations, during the debates, during the arguments, you have to justify and explain it in accordance to a certain article or whatever article number that satisfies your explanations to the public. Because if that is the case, you are not a lawyer. You always based on the opinion. Okay, your answer will be based on the opinion. What is logical only based on you. It should be factual based on the legalities, on the statements article per article. But this girl cannot never even mention at least one article during her statements. So there's a question. Is she really a certified lawyer? Because it doesn't match. It doesn't reflect and radiates to his actual personality and behavior, including her gestures when she spoke, when she uttered words to the public during her public speeches. It's gonna be like that. I cannot understand really until now. Sorry. Maybe I just have a very high standard. I think so, but I don't know, I can't explain. Mysterious, right? Meaning in the labyrinth of nowhere. You know labyrinth? Research that in the dictionary. Okay? Something like that. It confuses me a lot. Okay? See again, I read her statements in Tagalog. Okay? Like this. Do I have to interpret this in Chinese? Because I learned also a little bit of Chinese when I worked in Taiwan before. Mandarin, but only small. Okay? Like that, okay. Sigurado na ang panalo namin. See, this first statement is declaring certainty. You know, certainty meaning you are stating patapos. Okay. See, sigurado na ang panalo namin. Are you sure a lawyer will speak certainty even though the result is not yet coming? You get the point. You should revise your statement into a statement that is not declaring certainty, meaning not subject for confirmation pa, because it was not yet really happening. Okay? So you gotta change your statement. Kasi sigurado, meaning sure. Okay, sigurado na ang panalo namin. This is from statement of Lenny Robredo, April, what's that? Okay, Never Again by the Rappler. Maybe Rappler also make it more sweety. We don't know really. Okay, but it is possible they will also create statements. They are online news platform. Okay, so they should also write what this girl are talking, right? Of course. In journalism, you should put every time what comes out of the mouth for a certain person. You will not create your own because you are biased. Okay, so you are fabricating. So meaning to say, you are giving disinformation to the public. Okay, you get the point. So it's gonna be like, sigurado na ang panalo namin ni Kiko. Di mo nakakatawa? Pag natalo kami, ibig sabihin nadaya tayo. Di ba? Are you sure if you're gonna lose, you are cheated? Right? So ibig pala sabihin, you will do something bad if you will be cheated after the election. Because you said, pag natalo kami, ibig sabihin na daya tayo. And the last statement supports, pag nadaya tayo, magkakagulo. What's this? This is a threat, right? T-H-R-E-A-T. This is a threat. If there's cheating, they will do something, violence, whatever, chaos, because the term magkakagulo. Right? So, if you found that there's cheating, then why you do magkakagulo? Then do file a case, a legal case against to those who cheated your team, right? It's not this way because you are a lawyer. Do it in a legal way. Okay? So it doesn't really it doesn't really reflect her profession to her actual standing being a person. Sorry to say. Nakakaloka ka, sir. Really, this is an evidence already, right? This is her statement from Rappler. Okay? But if you try to compare this to Bongbong Marcos, Bongbong Marcos telling that this way, salitang patapos. This is, in journalism, this is closed statement. We have open statement and closed statement. Closed statement are more on confirmation, meaning certain, direct to the point, regardless of conditions or any time, whatever. But open statement is subject to changes. So you will use the terms that are not really fixed. For example, probably, maybe, I think, hopefully. Things like that in English. If you are not really sure that it's gonna be happening in actual. So be careful also when you put statements in the articles or whatever. I'm not a journalist in real profession, but we are trained to that since high school, okay, until college. Because I am also a member of the Editors Guild of the Philippines, okay. We are from Cebu Institute of Technology representative, and we are the editors of our public school paper, publication school papers. Okay, and also in high school, I also remember one of the editors of our publication school paper. And we know already what's gonna be like that because we are trained, we do a lot of trainings regarding this, how to make a good article, what is the title, what is the brevity of your content, something like that. Okay, we know redundancies, duplication of thoughts, jargon, like that, You get the point, mga palaga akong hitag. So it's gonna be like that. Hindi na nakakairita yung statement na mga ganito, di ba? Okay? So, mauna siya. Okay? And then, never again. Oh. Hindi na papadaya ulit. Are you sure? hindi daw sila papadaya ulit, oh. In fact, they are the one who cheated before, and they're telling the reverse that hindi napapadadaya ulit. In fact, their team are do cheat. They cheated the camp of Bongbong Marcos during 2016 election, but they reversed the statement favored to them. What's this? Okay, so it looks like only just like I know, a high school student brain cells, right? Not really a lawyer. Sure. Okay, kini ang na-statement diri ni Arnold Ando Espinosa. Kini ang kulba ug dili angayan mahimong leader kay di kadawat og kapildihan. This is a Bisaya term already. Okay, the caption here. Okay, there are 2.3k what's this comments. Oh my gosh, ang daming comments. I will look for the emojis. Wait, emoji, the reactions. Okay. I will just tell you. Okay. I need to open this one. How much? Because most of her comments and statements, so many don't like. Okay. Only if you will like this. Okay. If you try to assess the statistics of who favors, who like her statements. So many don't like her statements. Really. Okay? Nakakaloka. Okay? So it looks like buhaton dyan lang tanan para mo daog. Di makadawat og kapilihan, di ba? Nakakaloka. Nirita ako nga. Sorry. Sorry mo pala akong hitag. Because this girl chatted with me in the Philippines. Okay, she is older than me. We are neighbor. Because tomorrow is already election in our country. He said, Atay, biyan lini. Oy, way ayo. In Bisaya. See? FB Messenger. Like that. Okay? So, so this is a bad words. This girl chatting to me. Okay? And I cannot convert that in English because I found that also very difficult to translate. Okay, I will say, if I will try to translate this one, atay ben, so liver with this girl. It's very difficult, see? Atay beya aning lini, uy, ayaw sa una pag-English. Di ba, it's very difficult? Nakakaloka. Huwag na lang. Di ba? Nakakaloka. Naloko na ako eh. Diba? Ay, hindi na yung patulan. Dito na ako masaya. Char! Okay. So, balik na rin kay Yuna. Okay. Ano siya mga ito. Natay problem karon. But before that, mo exit sa ako gamay. Char! If you like this video, you can click the notification bell and then to comment, to like, whatever, and to make this video a short inspiration that you can share to anybody else also with regards to academic information and physics. Okay, like that. It's gonna be grade 12 or grade 11. I don't know, in high school. But sure, it's gonna be first year to first year college to second year college. First semester to second semester, physics also will be there. Right? More rigid compared to the high school physics. Okay? As far as I can remember, in our high school physics, we are not going to the angular momentum, torque. We don't touch that in our high school. But in college, you will touch a lot. Okay? Kaloka. You get the point, mga palaga akong hita. Bye-bye, God bless everybody. Diba? Kulbaan sa taling kuhan. Lini, nakakaloka. Magkakagulo, in fairness. Sige na nga.